in MATLAB Simulink utilizing the toolbox for the modeling and analysis of thermodynamic systems, or TMATS. TMATS is an open source MATLAB Simulink plugin that can be used for the development of thermodynamic simulations and contains a library of iterative solver blocks. Before we head into MATLAB, I'd like to give a little bit of a background on the techniques TMATS uses in its solver. I'm going to keep this fairly simple, and if the topic interests you further, I encourage you to do some web searches on it. There are a lot of other resources out there that go into a lot more detail than I'm going into. The TMATS solver method uses two different methods. It uses a Jacobian calculation for the system characterization, and then it uses a Newton Raphson for the iterative solving method. Here are the equations that TMATS uses. There's really goes in two main steps. The first step is determining the Jacobian or system gradient. It does this by perturbing the inputs and then looking at the outputs from the plant. It takes this Jacobian that it determines and then it uses it in the Newton Raphson to converge the system in the second part, utilizing this equation here. Now I'm going to talk a little bit about a simple example. Let's suppose you have an equation, here we'll call it f of x. So your goal is to find an x where f of x is equal to 0. So your first step is to find the Jacobian. So you make a guess as to what your first point will be. Here we'll guess that you're at x1 and x1 is equal to 6. You then determine what f of x1 is. Once you have that point, you perturb the system. So you pick another point that's maybe p away, p being a fairly small number, and you say x2 is 6 plus p, and then you determine your f of 6 plus p. From those 2 points, you can generate a slope. So you pretty much, that's what this equation is here. So you have f of x2 minus f of x1 over x2 minus x1. That's the slope or the gradient of that system. You use that gradient in the second step using the Newton Raphson equation here to essentially slide down that gradient and pick the point at which you hit 0, or f of x is equal to 0. The new x that's at that point is called xk plus 1. Once you're at xk plus 1, you determine your f of xk plus 1. And then that would be actually on the line on your f of x. You'll see that you're still not to that point, that 0 point, but this is where the iteration comes in. You do that again, essentially doing it over and over until your f of x is 0. So now we're completed with the background portion. We're going to head in and look at MATLAB and a few examples.